We discussed question 6 of A-Level Mathematics Paper 5, Probability and Statistics 1, in May or June of year 2020. The lengths of female snakes are normally distributed with mean 54 and standard deviation 6.1. We look at the length of female snakes. These lengths are normally distributed. So we have a normal distribution. The mean of the normal distribution is 54, and the standard deviation of the normal distribution is 6.1. We let x to be the random variable denoting the length of female snakes. X follows a normal distribution with a mean of 54 and a standard deviation of 6.1. Find the probability that a randomly chosen female snake has lengths between 50 and 60. We need to find the probability that X is in between 50 and 60. In order to find this probability, we need to make use of the standard normal table provided. So we have to standardize this, and we need to convert using Z equals X minus the mean. Mean is 54, and standard deviation is 6.1. So standardizing, we have 50 minus 54 divided by 6.1, that X becomes a Z, and 60 minus 54 divided by 6.1. So we have the probability that Z is in between negative 0.6557 and 0.9836. We need to find the area under the standard normal curve in between negative 0.6557 and 0.9836. For the standard normal curve, we have negative 0.6557, and we also have 0.9836. This area will give us the required probability. The standard normal table given to us is a left-tail table. So we find the area where Z is less than or equals to 0.9836. So we must find this area here. The table will give us this probability, and we need to subtract the area that we do not want. We have negative 0.6557. We do not want this area. So we find the probability that Z is less than 0.9836, and we subtract the probability that Z is less than negative 0.6557. Probability Z less than 0.9836. We can read this from the table directly, and this has a value of 0.8375. The probability that Z is less than negative 0.6557. To find this area here, we need to make use of the fact that the standard normal distribution is perfectly symmetrical about the mean. The table gives us a left-tail region on the right of the mean. So instead of finding this area, which is not possible from the table, we can use the symmetric nature. This is 0.6557, and we find this area. These two areas are the same. but the table will give us the left tail area. So this area that we need to subtract is 1 minus the probability that Z is less than 0.6557. So we subtract this area from 1 and we get the area that we want, which is probability Z less than negative 0.6557. So this is 1 minus probability Z less than 0.6557. So we have 0.8375 minus 1 minus the probability that Z is less than 0.6557. And this is 0.8375 minus 1 plus the probability that Z is less than 0.6557. This probability can be read directly from the standard normal table, and it has a value of 0.7441. So when we take 0.8375 minus 1 plus 0.7441, we have a value of 0.5816. Part B, the lengths of male snakes also have a normal distribution. So instead of looking at females, we look at males now. And let's say we denote this random variable by y. Y follows a normal distribution. Let's see. A scientist measures the length of a random sample of 200 male snakes. He finds that 32 have a length less than 45, and 17 have lengths more than 56. Find estimates of the mean and the standard deviation. We need to find the mean and the standard deviation of the lengths of male snakes. 32 have length less than 45. So probability the length of a male snake is less than 45 centimeters. That is 32 out of 200. 32 out of 200 is 0.16. We are given standard normal table. In order to find anything, you have to standardize. You see normal, you standardize. Standardizing y gives us Z, and then we have 45 minus the mean divided by the standard deviation. That is 0.16. Now Z less than a value less equals 0.16. The probability that Z less than a value, you start shading from the left until you have an area. This area is 0.16. This Z value here is 45 minus mean divided by sigma. So this Z is 45 minus mean divided by the standard deviation. Our left tail table is to the right of the mean. So, and then we're going to find this from the table. Instead of finding this, we'll use the symmetric property. So that is 0.16. This Z value is the negative of this other Z value here. Let's say this is Z sub 1, this is Z2. This Z2 here is the negative of Z1. And we can find Z2 by looking at this area. So this shaded area here is 1 minus 0.16, which is 0.84. We use 0.84 for the area, and we read back to the first column and first row to find that Z2 value. This Z2 has a value of 0.994. And Z1 must be negative 0.994. Then we say that 45 minus mean divided by the standard deviation, that is the Z value, that is negative 0.994. Multiplying by sigma, 45 minus mu is negative 0.994 sigma. That is equation 1. We are also given that 17 of the 200 snakes have length more than 56 centimeters. So probability that a snake has a length greater than 56, that is 17 out of 200. 17 out of 200 is 0.085. We can standardize the left side so that probability Z greater than 56 minus mean divided by the standard deviation is 0.085. Now let's look at the normal curve. Probability Z greater than a value. We start shading on the right until we have an area of 0.085. Then this Z value is 56 minus mean divided by the standard deviation. But we cannot use 0.085 because we have a left tail table. Then to find this area, we take 1 minus 0.085, and this has value 0.915. So we look at the area of 0.915 and read the first column and the first row to find a Z value of 1.372. 56 minus mu over sigma must be 1.372. Multiplying by sigma, 56 minus mean is 1.372 sigma. That is equation number 2. We need to solve equation number 1 and equation number 2 to find the value of mu and the value of sigma. We can subtract these two equations. Mu is gone. We are left with 11 on the left. On the right, you have 2.366 sigma. Sigma is 11 over 2.366. So that sigma is 4.65 centimeters. We found the value of sigma. To find the value of mu, we can substitute sigma equals 4.65 into either equation number 1 or number 2. Both works. I'm going to use equation number 2. 56 minus mu is 1.372 times 4.65. That is a value of 6.3798. 56 minus mu is 6.3798. Rearranging, mu is 56 minus 6.3798. Mu is therefore 49.6 centimeters.